Hey guys, in this video we're going to learn how to compare populations to one another. So far we've learned how to summarize one population or one data set using our measures of center, mean, median, and mode, and our measures of variability, which were the IQR and the mean absolute deviation. In this video, now we're going to use those measures to compare two populations to each other. And one of the tools we're going to use is called a box plot. And I have an example of a box plot here on the screen. And a box plot shows just a few critical data points in our data set rather than showing all of the data in a data set. It just summarizes them using 5 key points. It shows the minimum, the maximum, and Q1 and Q3, and the median. It's also known as a box and whisker plot. You may have heard it called a box and whisker plot before. So several things we can get out of this is the range of the data set and the IQR very quickly. So the length of the box tells us our IQR when we're trying to find these statistics that we're using to summarize our data set. And a double box plot is a box plot that just shows 2 data sets on a single number line. What I have here is just a single box plot, but a double box plot would have 2 box and whisker plots on it. So let's take a look at one. So here's an example of using a box plot to compare 2 populations. And here Casey surveyed a group of students in her science class and in her math class. The double box plot shows the results for both classes. What we want to do is compare their centers and their variations. And we want to write an inference that you can draw about the 2 populations. And an inference is basically like a conclusion. What can we conclude about the data? What can we say about the math class and the science class when we compared how many blogs they posted this month? So what we want to do is for each of the populations, we want to compare the centers and we want to compare the variability. So looking at the box and whisker plots, we're looking at the centers, and to find the centers, we're going to look at the median. So for the math class, the median was 10 blogs for that month. And for the science class, it's here, and it's 20 blogs. And that's comparing their centers. And now we want to look at the variability from each class too. So we're going to look at the IQR, which is the width of the box. And for the math class, the IQR goes from 5 to 20 blogs. So that's an IQR of 15. And for the science class, it goes from 15 to 25, and that's an IQR of 10. So now we've collected these pieces of statistics here for these 2 populations, and we want to make an inference. Well, what can we conclude? What can we say about the math class and the science class when we compare them to one another? So what we want to do is write a sentence for each one of these statistics. We want to write a sentence that has a conclusion we can draw about the centers, and we want to write a sentence that has a conclusion from the measures of variability, or the IQR. So looking at the centers, what can we say? Well, it looks like the science class blogged more. And that's maybe an inference or a conclusion we could draw, that the science class typically blogged more than the math class. And then what can we say about the variability? Now remember, variability doesn't tell us how much they blogged. It told us how consistently they blogged, or how alike our numbers are. So it looks like the science class had a smaller IQR, so it looked like they were more consistent, or their data was more consistent. So a couple of sentences we could write would be something like this. Typically, the science class posted more blogs than the math class. The data for the math class was less consistent or more spread out than the data for the science class. That right there is an inference. So when you're asked to draw an inference, it's basically, what can we conclude? What can we say about the 2 populations once we've compared them? And it's usually nice to write a sentence for each, a sentence that compares the centers and a sentence that compares the variability. We can also use the mean and the MAD to compare populations. Now, in the last example, we used the median and the IQR, but we can also use the mean and the MAD. So here we're comparing the quiz scores from two classes, second period and fifth period, and we don't have a box and whisker plot, we have a dot plot. So we can find the mean or the average because we have all the data points here, and I already did that. So for the second period class, the mean or the average was 16 points on the quiz, and for fifth period, the mean was 17 points. So those are our measures of center for these two populations. And now I want to find the measure of variability. So remember, to find the MAD, we have to find out how far away each score was from the average. So for second period, I'm going to list how far away they are from the mean here. So this score was 2 points away from the mean, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, and 2 points away from the mean. And when you add all of those up, those add up to 10. And we average those to get the MAD, and there are 12 scores. So 10 divided by 12 gives us an MAD of 0.83, and I rounded that to the nearest hundredth. And for fifth period, we have to find out how far away each score is from 17 points, or their average. And this is 3, 2, 2, 1, 1, 0, 0, 0, 1, 1, 2, 2, 3. And then again, we would add all of those up, and those add up to 18. And there are actually 13 scores in fifth period. So we would divide by 13, and we get an MAD of about 1.38. So now we have measures of center, and we have our measures of variability. So now we need to make an inference. We need to make a conclusion. What can we conclude about fifth period and second period quiz scores? Well, judging from the measures of center, we could say that typically the fifth period students scored better. Not much, but they scored better. And then if we look at their measures of variability, we would see that they were a little less consistent, though. Their scores were more spread out. They have a larger MAD. That tells us that there's more variability in their scores, or they're less consistent. So if I was to make an inference or a conclusion, I might say something like, typically, fifth period students scored better, but their scores were less consistent than second period. How do we know when to use which measures, though? Should we use the median and the IQR, or should we use the mean and the MAD? Well, here are some helpful tips to decide when to use which ones. We should use the median and the IQR when the data are in a box plot. If you have a box and whisker plot, you cannot find the mean and you cannot find the MAD. So it's impossible. You have to use the median and the IQR if they're in a box plot. So that's an easy decision. Or when one or both of the data sets are not symmetrical. So what does that mean for a data set to be symmetrical? I have an example below. If you have a dot plot or dot plots for your data, the one on the left is what a symmetrical data set would look like. It kind of looks like each side is almost a mirror image of the other side. And then on the right, I've got an example of a data set that is not symmetrical, so that you can see that it's kind of lopsided over here. Most of our data are clumped over here, or when you see gaps in the data set as well. This would be a non-symmetrical data set. So when you have that, you would typically want to use the median and the IQR. You can use the mean and the MAD when the data isn't in a box plot. So if you have dot plots or just raw data, and both of the data sets are symmetrical. So we want to look for symmetrical data sets if we want to use the mean and the MAD. So when comparing two populations, first thing we need to do is decide which measures of center and variability to use. Should we use the mean and the MAD, or the median and the IQR? And I just talked about that on the last slide of when to choose which one. Now, what you don't want to do is mix the mean with the IQR or the median with the MAD. They just don't go together. The mean and the MAD go together. They're like peanut butter and jelly, and the median and the IQR are like ketchup and mustard. You don't want ketchup and jelly, and you don't want peanut butter and mustard. It just doesn't go together. Secondly, we want to compare the centers and compare the variations. These are two different angles that we can look at the data set from, the centers and the variations, and then write a couple sentences that makes an inference or a conclusion about your comparisons. Write a sentence about the centers and write a sentence about the variations. And that is how we will compare two populations.